I'm recording. Okay, so welcome. For some of you, I saw the names. You have come to my other sessions, so thank you for returning and participating again, and welcome to anybody who's new. My name is Betty Morris, and I am one of the math learning facilitators with Edmonton Regional Consortium, who we work now for the part of our responsibilities is also to work for the province at the regional provincial level, which is the ARPDC, the Alberta Consortium. And so we go back and forth now and work between the two. But all my sessions, they're under ERLC, but they all go out to the province. So welcome. Anybody who is not within the Edmonton Regional Consortium, or even anybody who's within the province, anybody who is here that may be from an international school or another country, I welcome you as well. Today's session is on grade 5-6 number. Now, when I looked at the names, I saw that some of you have been to my sessions before, and that's great. And so you're going to see a little bit of a repetition because I kind of have a routine that I always start with. And I do this only because in all of the sessions, there's always someone new that comes, and I welcome you if you are. And so those of you who have come repeatedly, you'll see some repetition in some of the slides. But that's just a reminder, and you can, when you get the slides, you can ignore those. Although sometimes watch the slides with the sites on them, because I'll put some new sites on depending on whatever we're doing, what learning outcome we're doing. So there is some repetition there, and I do have slides that I have from grade 4 as well, if you've been to any of the grade 4 sessions, because I need to show that learning progression. So I just wanted to acknowledge that right from the start. Okay, so we'll go right away, first thing, into our land acknowledgement. I'm just going to move this up. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional treaty lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. Spanning generations, acknowledgement of the land is a traditional custom of Indigenous peoples and an important part of reconciliation. It gives voice to the authentic history of the land and its original people. Honoring the land in this way acknowledges the story of the creation of this country in a way that has historically been missing. Okay, so I introduced myself. I did not say where I was originally. I'm originally from Edmonton Catholic, and then Alberta Learning, did a few other things, went to work in other countries, specifically Africa, and just had a wonderful experience working with ministries, private schools, public schools, individual teachers, students, people within the ministry. Learned so much, saw so many and experienced with so many excellent teachers in very, very diverse environments, very diverse environments. One was even in the field, as wherever the animals went, that's where the school went. So, and then now I'm back here with ERLC, and hoping that my sessions will help you to understand the new math curriculum grade K-4. 4-6. As well, most of you will know, but for those of you who are new, you will get all the slides that I present today, and I've got lots of slides today. Some of them we're not going to go through so much. I just wanted to give you, when I send them to you, I wanted these slides, the extra slides, to give you more information. So I put extra slides in for this particular session. So you'll get the slides, plus you get added notes. So sometimes if you don't have time to read listen to the recordings, or maybe I don't sound so good on them and I'm a little bit jumbled, you can certainly go through the notes. So the notes are just, these are some of the things I said when we were talking, and I don't want you to forget them. So all of you will get those. Now you will get the slides as soon as I do the notes, but I'm going to be a little bit late this time. So I try to get them within a couple of days. Hopefully by the weekend, you'll get them. I'm just going away to do some professional learning for school districts. So, and then I send the recording to the admin office, and then they will at ERLC, and then they'll send it off to you. So I like to send the slides myself to you because I always maybe have some extra comments in the email. So you'll get those as soon as possible. So what I'm going to share today with you, we're going to look at grade 5. Grade 5 and 6, because those are the two that are closely related. I like to do, teachers have asked if we could do individual grades. So I did an individual grade for grade 4 session because it was pretty important. Grade 5 and 6 I put together. For this will help for the grade 6s to see what the grade 5s are going to be learning. Grade 5s, you're going to see what came from the grade 4 and what understandings your students are going to come with, hopefully. But as well, if you're in a combined 5-6, this wasn't meant to be a session for combined, but you're going to see that you'll be able to do things together with the students. So we're looking at place value for grade 5. There is no learning outcome for place value for grade 6, but it's important for the grade 6 students and for you to understand what's new about place value, if anything. And it's not so much what's new. There's a little bit of a twist and something you might want to reconsider or think about when you work with the students. And also that fact that we're now looking at patterns in place value. And then adding and subtracting. Grade 5's within 1 million, and grade 6's, it's just general, similar to what you were teaching before. If you have taught grade 6 or did teach grade 6, that they're going to solve problems using standard algorithms. So most of our discussion today, we're going to talk about this little bit of a different look at place value for grade 5 and grade 6s, because you're going to be doing it as well when we get into the algorithms. So quite a bit of our discussion today is going to be looking at that notion of standard algorithms, which we would say, well, that's not really new, and I've always done it, but we're going to look at it relative to what they're saying in the new program of studies. So a little bit on resources, and then at the end, of course, I always like to give you some little activities that you can take back with you right away. And I always like to start out with a warm-up, just like I do in class when I work with the students. So this one is with decimals. You'll get anything that's shown here, you get that on your slide page with all the sites, plus at the bottom of each slide. So you can just have a look at it. And if you want to in the chat room, I'll give you a couple of minutes or 1 or 2 minutes to tell me which one do you think doesn't belong. And rather than writing it all out, you could say the top left box or the bottom right box, or if you want to, just have a look at it and see which one do you think doesn't belong. Maybe the top left, okay? And Carrie, if that's okay with you, I'll just answer the top left. If that's your answer, if you can either give me a little thumbs up or whatever, but I'm assuming the top left because it's in words where the other ones are in numbers or numeric form. I'm hoping that was what you said or your thought. Yeah, good. Thanks, Carrie. Bottom left, 10 times greater than the others. Oh, that's interesting. Okay. Yes, because it's 2 and 439 times 100, which is going to make it 10 times larger. So the result of that, or the other form, the number itself is not the same as the others. Perfect. It's a good way to write it. The words, the bottom left again, Maria said, yeah, the one with only words. And then we have, if you're going to do this with students, because we are going to talk about decimals, then you have things like, well, that one's got brackets and that one's got multiplication, but so does the other one, but everything is times 10 and they're multiplying it like lots of numbers together. You'll see students, that one is bigger. The 24 and 39 hundredths does actually look bigger than the other numbers, and they may say that. So, and then you've got the words. So again, that's just because you're going to be working with decimals, that's something that you are going to be able to work with the students, and you make up your own as you go along. Thanks for sharing. then the next one, we're not going to do this one, but this one comes from Math Up, just another kind of a math talk. And the reason I like this one is because it's representational. What number could you show on the place value chart with 12 counters? And that's one where the students would use the counters, or they could use dots, or they could use ticks. We're not looking for numbers or digits. We're just looking, you've got 12 counters. And the great thing is that if you use the mini whiteboard, as I say in every session, it's my favorite material to use. And they can draw the hundreds chart, put the counters on, and then always get them to write the numbers. What number is it? Say it and write it. Say it and write it. Oh, no, are you talking about the decimal question, the one before? There is no correct answer. That's a good question. Yes, good question. Because we often don't think that in which one doesn't belong. And if you have never been to the site, Carol, when you go to it, you're going to see so many. The reason why we use it as a number talk or a math talk, because there is no right answer. It's whatever the student whatever they see. And those kinds of questions, we try to get them as what we call low entry and high ceiling. So sometimes students will say, well, that one is bigger because it's written bigger in a bigger font, or that one has got words, which is a good, that's perfect because they have to know that. But there's no wrong answer. It's whatever the student sees. And if they can justify and reason why they chose that one, it could be color. Maybe one is going to be written in pink, because those students who only see color or shape, that's what they'll do. So there is no wrong answer to any of these. Okay, makes sense. Okay, and then we've got this one here, where they would do the 100 chart, and then they would do the different ways that you can. We do this with the small students, the lower primary students, when we give them base 10, because that's more concrete and you can actually see 10, 100, and 1. This is what we call representational, and so they're just using the counters, or they could use circles or whatever. Okay. So I'm just giving you that one. Now, this is your sites, and you get this every time. So the sites used in this presentation, now you're going to see, some of you will see, I repeat because I'm not sure who's going to be here. And then I try to add any kind of sites that will deal with decimals in this case, or whole numbers or operations. And one of the things that you're going to see a lot of that we're going to discuss is Khan Academy in a very good way. And actually, I've been watching a lot of his videos. Initially, I thought, no, it is more of that traditional algorithm. But when you really start to listen to him, and he's like me, talks a little bit fast. His videos go fast. If not for the students, then for you. And I'm going to show you which ones that I definitely think you need to watch. So we're going to look at those. So these you'll get, so you can go and visit these sites. And again, oops, that one should have been discarded. But you've got the outcomes again, the 5N patterns, add and subtract, and then the grade 6 is the algorithm. And we're going to look at what's different, what's new, the vocabulary, any new knowledge and understanding, what the students, and we're going to talk a lot about what the students' prior knowledge that they may have come from the previous program of studies. That's really important that will help you. And I think in a lot of cases, they do come with that. And again, to think about. And this particular information, when we look at our curriculum and looking at it through what we value and our personal experiences and what we know and understand, it hits home so for this particular session, because this is about adding and subtracting with and without regrouping whole numbers and decimals. And it is about that. This is the way we were taught, and therefore this is the way I think that I understand best. I'm not going to say that you teachers say this is the way it should be taught, but that's what they understand to a certain extent. But a lot of teachers have said to me, I didn't know what to do, but I didn't know what I was doing. And that's where that second statement about the understanding. So we are going to talk about a traditional algorithm, a skill or a procedure, but the importance of understanding it and not just doing it. And then this is for me, because a large part of these sessions I do because I want to help support you as a teacher to understand the math that's behind it, and so that you can therefore then help the students. And this is really important to me because I have background in this, or training in this, and it makes so much sense to me. So again, it's because we're looking at the curriculum. What do I want my students to know and understand? That's what we're doing in these sessions, is the curriculum. And then there's the two other pieces that go with it. The next question you ask yourself is, how will the students they show that they understand? And that's where we're looking for that evidence or assessment. So how am I going to, I know what I have to teach. How am I going to know if they understand, the students understand? And then you plan the strategies to go along with that, to get them so that you can assess for that understanding. And the simplest example I can give you, and which is years ago, where we taught and we didn't think about how we were going to assess. We just went ahead and, whether we followed a book or took our own ideas. And then we found an assessment task that was a performance task where maybe there was a rubric, but nothing had been done throughout the unit on doing a task like that. And so the students struggle. Very simply, it's if you're going to ask them questions, if you're going to get them to explain or draw or do anything, an interview, then that's what you need to do in your activities as well. And just an aside, high school teachers now, because of artificial intelligence and all of these students being able to go to these sites and getting essays that they're handing in, and with no plagiarism apparently, but these sites will generate a wonderful essay. High school teachers are now saying, well, then I have to look at assessment differently. If that's the case, because that's not written by that student, then I have to look at things like interviews, maybe a different format. And so that applies the same to us in math. So these are the documents. This is the bridging document for grade 4 to 5. It's very simple. I've given you the site, but it's saying that in the new math grade 5, they're asking them to use standard algorithms to add, subtract, multiply, and divide. Whereas in the previous grade 4, they were using chosen strategies, which they still have to do in grade 4, which they're called personal strategies now. But I'm going to say to you, I'll say it now and I'll say it again, I would venture to guess that most teachers, they felt it necessary to move their students in the previous program of studies into a form very close to, because we're going to talk about what standard algorithm means, but some kind of efficient method for doing the 4 operations. So it's not, even though it's in the new curriculum, it's not necessarily going to be new to your students, but you'll have to watch that. And then grade 6 is the same. So in grade 6, they're going to use the standard algorithm again. And in the previous grade 5, it said demonstrate proficiency. This is the new curriculum, demonstrate proficiency with an appropriate and efficient strategy. But your students are coming from the previous program of studies, and I would venture to guess again that you, if you have taught grade 5 or the grade 5 teacher, probably worked along with grade 3 and 4 teachers with different strategies, but worked up to that standard algorithm. And I'm optimistic about that and positive about that, but you may have to go back, of course, and work with that if that's not the case. These other documents, these are just for you to look at, is your interactive planning year. You can see lots of yellow for grade 6 because this grade 5, because this is showing you that you should need to start small. Grade 5 is whole numbers, large whole numbers, and then decimal numbers to the thousands. And then this, if you've not, I think this for all of you is going to be new because we've got a draft for you. So I've talked about this verb document where you have the definitions of the verbs. So there's this particular document where you're going to get the verbs and the definitions, and then you get a card. Those are ready. I've given you the access to those. So you'll get all the definitions. That glossary is in a document, and then you're going to get these cards that you can look at. Now those cards have been stamped draft, but you're going to have access to those. You will not have access to it. You can see that there's a link to this in this glossary, but that is just a link from the verb to the document here, the card. that those links aren't ready yet. So you have to work with the two documents side by side, but you will get those so you can access those right away. Those are, for those of you who don't know about this document, those are the verbs from the skills and procedures, and they explain what that means, what those verbs mean. Okay, so let's look at place value. This is just very quick. This is just to let you know to read your document, but you already know how to read your curriculum document. So this is what we want our students to know and understand, and this is how they're going to demonstrate their knowledge and understanding. And you know that, but I'm going to send those to you. So because the coming grade 5 and 6 students will not have worked with the new grade 4 or 5 curriculum, it will be important to look back and see where the gaps in learning may occur. And I say may because I think that in some cases you are going to have to do some catch up because the students didn't have the new curriculum. And so they're going to be missing some of those knowledge and understandings. But in some cases, it's going to, you're going to see that, yes, they do have some understanding. So this is, I've got a couple of these and I'm going to have to be very slow at explaining them because there's, so I can explain the reason of how I organize this. So what are the previous learnings? So when we look at grade 6, there is no learning outcome for place value. So that's why it's blank. But grade 6 teachers who are here today, you need to listen to this and you need to look at this because you are still going to work with place value, in particular when it comes into multiplication and division, of course, but even in the decimal part of it, really important. So in the learning outcome for grade 4, the new learning outcome is that they're going to apply place value to decimal numbers. And in grade 5, students are going to apply patterns to place value. So it's a bit of a different look. The wording is different at looking at place value in grade 5. But you can see in the new curriculum, they apply place value to decimal numbers. Well, your students who come from the previous document, they have done that as well. There are learning outcomes and these knowledge statements and understanding statements that are very similar to what they had before. They just may not be under the title of cusps. So what I have for you, so that when you read it on your own, the understandings in red, those understandings in red, I'm saying that the students may have understanding from the previous program of studies. So they're going to, even though that's the new curriculum, they're going to come to you with some understanding of those pieces are in red because they worked with the old curriculum. So I hope that makes sense to you. I wanted you to see this visually so that you can see that the ones in black, those are the ones that they may not have an understanding of. So decimal numbers are numbers between natural numbers. Now, the reason I didn't put, they learn about decimal numbers in grade 4. The reason that I didn't put natural numbers in red was because that's not something we've used. Now, that is part of the curriculum, that is vocabulary. We've got anchor charts, we've talked about math walls. You can use the word natural numbers, but I would venture to guess that your students would not come with that knowledge of what it is. Decimal numbers are fractions with denominators of 10 and 100. They should be coming to you with that. It's the etc. part, because if they understand a pattern, they could go beyond 100, but they probably didn't go beyond 100ths in grade 4. So, but they know that the separation between wholes and parts can be represented using a decimal notation. They will come with that. It's part of the new curriculum in grade 4, but your students will have that understanding. This is where students will not come with that prior knowledge, which it would have been good for them to have. Patterns in place value are used to read and write numbers, including wholes and parts. I think what we do as teachers, we do it incidentally. We talk about that part. They can see the hundreds and the hundredths and the 10 and the tenths, but in the new curriculum, they're asking you to pay very close attention to that, because in grade 5, the understanding is place value symmetry extends infinitely to the left and the right of the ones place. So you can go, if you understand the pattern, you can go to the left as long as you want, as far as you want, and to the right. You only have to work with thousands, but you should be able to see the pattern. If it's thousands, 10,000s, then it's thousands, 10,000s. Okay, I'll show you what that looks like. So here's where it's a little bit different, and I'm only introducing this to you to see how you feel, because I want you to see the pattern. When we used to keep this, and I'm just going to go right to the pictures here. When we used to do the place value chart, and I still do in many cases, we put the ones in its own column. But when you're looking at the pattern, the notion is that the ones and the decimal, this is kind of like the base or the initial piece of the pattern. So it says in place value symmetry, the definition of it that I researched, the place value names are nearly symmetric around the ones column, because if it was totally symmetric and I drew a line, we have on one side we have ones, and on the other side we have the decimal point, which is and. So it's not symmetric there, and that's why I put the box. Because, and you'll see below, I've got the decimal, and you're going to see in other slides the decimal point in the ones box, because then it makes it easy then to see the symmetry, tens and tenths, hundreds and hundreds, and so on. Now, again, this is something that you need to understand so that you see, oh, I see the symmetry, I get it. And then the difficulty will be with some students, when you introduce it like this, the visual, they'll get that. If you ask them, go to the left as far as you can, and now go to the right, if they saw this kind of a visual, they'd be able to get it. It's when we get into the operations, where do we put that decimal point, in its own column or with the ones? And this is the extension, is the understanding of that vocabulary. If I add a thousands place next to the left of the hundreds, then I add a thousandths place to the right of the hundreds. And so we go back and forth, and we see that symmetry. And I wrote in the box here, emphasize that the decimal point is in the ones column in the chart, not in a column by itself. But when you get into operations, we'll talk about it, you may, because you're not talking about symmetry and place value anymore, you're talking about operations, you may choose to move that decimal back into its own column, only because you want to line up the numbers. So it's up to you whether you want to show this to the students, as long as you understand it and in some way get the students to see that going to that left and right. And then now we're looking at the knowledge statement. So here again, this is the grade 5. A number expressed with more decimal places is more precise. So if the further we go to the right, the smaller that the spaces come between the decimal points, and it's more precise. And it's what I call precision. And so we think about something as simple as if we went and just said 1 and 2 tenths, as opposed to 1 and 25 tenths. So they can see that we get more precise, especially when you're working with money. It makes more sense to do that. And a 0 in the rightmost place of a decimal does not change the value. That's something from the previous program of studies. We know that. And there are infinitely many decimal numbers between any two decimal numbers. So there's an infinite number. There's not a finite number between any two decimal numbers. So again, the understanding in red, those students probably will come with some knowledge. So they know that numbers can be composed in various ways from the previous. So you just using place value, most of it will be standard notation. They'll know that 456 is 400 plus 50 plus 6. A 0, this is in the new curriculum, but they should have known it from the previous. A 0 to the right does not change the value. And the word and, we say 46 and 2 tenths rather than the decimal point. I said to the grade 6s, I believe it was, or in another session, maybe the new teachers, it's so easy for us to say 2.5 or 2.5. And I think I hesitate to say 0.5, but after a while saying 2 and 5 tenths, you need to say it a lot at the beginning. You need to say it the correct way. And then sometimes it's just easier. I get caught all the time. It's easier to say decimal, but just make sure that they know that it means and. So there you see again, they're coming with this knowledge. What this part, the black part, is the part that you may have to work on. And that is for numbers in base 10, each place value has 1/10 the value of the place to its left. And again, for multiplying or dividing, we shift. If we're multiplying, we shift to the left by 10. If we're dividing, we shift to the right by 10. And those sentences, those statements, those knowledge statements, they're a little bit hard to wrap your head around. I'm going to show you a visual just so that you get a sense of what that means, but they do have to know that it's 1/10 or times 10. And then this one, which is not new, is new. The decimal separator is a point in English and a comma in French. And they have to know that. French and English are going to have to know that statement. So you're going to have to practice at some point, in particular with money, I would say for sure, doing that comma. I'm going to start with the one where a zero placed in the rightmost. So this is just a visual to show you, and you can show the students that 6/10, 0 and 6/10 is the same value as 0 and 60/100. They may look different, but they have the same value, and that's really important. And you're going to want to talk about that zero, and if you want to try and get them into that routine, be sure to teach equivalent values before operating with decimals, because you're going to get something like this 3 and 5/10 and 4 and 67/100. And when they transpose it or transfer it to the vertical form, they're going to get mixed up. The reason I say this, and I don't know what the grade 6, those of you who are in grade 6, I'm not really definite about what's happening with the grade 6 PATs, but historically, all of the questions were in horizontal format. And I was fortunate enough to do a project in the previous program of studies of the grade 6, where I had to take all of the provinces, grade 6, the provincial answers that they did. I could only do so many, and I had to analyze where students were going in every question in part A and why they did that and make a code for it. And I'm going to tell you that a large part of the population, percentage of the students, the reason that they may have got the answer wrong was because they would add 5 and 7, taking the last digit. They would keep answering it horizontally, and then they would get mixed up. Now, of course, I have, you have your, is that what they're going to do now? I'm not sure. But many times in many practice questions you get, it is horizontal. So it's really important that they use that zero, not just to add it because it makes two digits after the decimal, but because it has the same value. That's really important. And this is just an aside, and some of you may have seen it. It's excellent. This is a very old book, but when we talk about that, a number expressed with more decimal places is more precise. This is a perfect example. It's an old, written in the 60s, I think. It's a chapter book, The Phantom Toll Booth. It's all about math, but this particular passage is all about the whole thing of, every family has so many 1.25 children, 1.28 children, and they have 1.3 or 1.5 cars. That's an average. And this, when he goes to see this, he actually meets in the book, he meets this person, this boy, there's only half of him because there's 2.5 people in each family, and he's the 0.5. But he's lucky because then he can drive the portion of the car that nobody else can drive. So, but it's just a really good way. It's very visual, and it's such an old book. I think you can find it on, they do chapters of it on YouTube. So just to let you know that you can talk to the students about that. And now I'm going to show you an example of, there are infinitely many decimal numbers, and that's exactly what this is showing here with a number line. So that little arrow is pointing to any one of the numbers that falls between 2.4, 2 and 4/10, and 2 and 5/10. And the sequence of numbers that never ends. There's an infinite number. And these are just examples, and you can get the kids to generate. So what are the points that come between, decimal points that come between 2 and 3? Well, it could be 2 and 1/10, or no, I'll say decimal, 2.1, 2.11, 2.11. It could keep going, or 2.1, 2.12. It goes, and just get them to keep writing it and writing and writing it. And they'll say, well, enough is enough, just so that they experience what infinite means, that it's never ending. Then we're going to go into skills and procedures. Okay. So there, I've bolded, put in black bold the words, the verbs there: relate, express, relate, determine. And again, this is grade 5. Those are the skills and procedures: relate the names of place value, express numbers within 10 million. Now, again, the grade 4s that are coming to you have only worked up to 1 million with understanding number and adding up to 10,000, I believe, in operations. Now there's grade 4s. We're saying that they would probably go to 100,000 in the addition and subtraction. There is no number put for the grade 4s. So your students are coming, grade 5s, they're not coming with you would have to start probably at 1,000, 10,000, work up to 100,000, 1 million, but do that pattern. If you do the pattern, they'll get it, because in grade 5, they have to go to 10 million. And grade 6 teachers here, those grade 5s this year, in the previous grade 5, they've not worked with those big numbers either, but the expectation is that you'll operate with large numbers. So again, it's important for you to know that. And here again, in red, this is what I would say. I'll try to get to my chat questions. On the previous slide, the visual for shows 7 columns. Shouldn't there be only 6? Oops, okay, let me look. On the previous slide, the visual for, oh, I see what you're saying. Thank you, Carol. For as many times as I've shown that, you're talking about this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 3. So I should change this to 0 and 7/10 and 0 and 70 hundredths. Thank you, Carol. I don't know how many times I've shown this, and no one has caught it. So thank you. So we'll get back to this, to the skills and procedures. You can see in red, this is what, from the previous program, this is what the students will know. Identify the place value. They would have learned that within the previous program of studies. Determine the value of the digit, express using words and numerals, and different compositions of number. And there's where I say again, they may only have dealt with standard notation. So different compositions may be something like 320 is 300 plus 20 plus 1, but it's also 32 tens plus 1, 1. So you'll have to see if they know that. They may only come with standard notation, but there's a large piece of it that your students will know. But relate the values of adjacent places, including tenths and hundredths. They may not have that, because again, that's relate the values of adjacent places. And what we're saying there is, again, that 10 ones is 10 tens, 10 tens is 100. It's that multiplication. We're multiplying by 10 as we get larger, and we're dividing by 10 as we get smaller. That's the relationship, and it's a consistent relationship between the values. So that, again, in grade 5, you're going to have to relate the names of the place values that are the same number of places to the left and right of the ones places. And it's just how many tens, how many ones, how many tenths, how many hundredths, and relate them by saying it's 10 more, or times 10, it's 100 more, it's 1,000 more. Again, that pattern. Express numbers within 10 million, going to decimals to thousandths using words and numerals. Relate a decimal number to its position on the number line, and determine a decimal number between any 2 other decimal numbers. Now, if you've done the previous one and you've have the students experience writing all the decimals between 2 points, they won't have any trouble with determining a decimal point. They will have had that already. So I'm just showing you this again. This is our symmetry. This is the way it's how you can show it, but it's very important for you to understand, because now I'm going to go to this one. And this is where I put This is where I'm going to show you how they relate. This is a visual of how the ones and tens and hundreds and tenths and hundreds, how that moving to the left and moving to the right relates to each other, that it's always 10 times more or 1/10 of. And I put the decimal point in here. So I'm going to multiply this by 10. And one of the things I would like to stress or to recommend for you is that when you think about this yourself, you are multiplying that number by 10. You are not multiplying each digit by 10. You are technically behind. Every number is going to be, every digit will be multiplied by 10. But I need you to think of this, or it's important for you and the students, for them to understand first and foremost that you are multiplying 95 and 71/100ths by 10. And then you're going to go through that process. So when you multiply by 10, a visual is you're going to the right, to the left. I said the wrong way. You're going to the left. The number, your multiplies, again, your meanings, you work with them, they get larger. And I would recommend grade 6 then you do the same thing with your students, that you do this with your students. So you're going to the left and you're multiplying then you're multiplying each digit will move to the left. So now you have 95, 970, 57, sorry, and 1/10. Notice that the decimal point did not move. It was the digits that moved. And I only say this for you to think about, because oftentimes, and I did too when I taught grade 6 and junior highs, I would say, if you're multiplying by 10, move the decimal point one place to the left. Now, I'm not saying that's wrong, but for me, what I failed to do when I was first teaching is I don't think I understood that I was multiplying that whole number by 10 and therefore every digit. I'm not moving the decimal point. It's the digits that will move to the left. And so that's just something you need to understand, even though you say move it to the left, or we used to do the mountains or whatever. It's really important that they know. Again, I have to say you're multiplying the whole number. So notice that the decimal point does not move. The digits within the number move. Remember that the entire number is multiplied by 10. And when you multiply, the number moves to the left in the place value chart, because we're getting larger. When you divide, the numbers move to the right, because then you're dividing the numbers. The final answer will be smaller, or less. Try having students investigate and discover the connection before teaching the rule to move the decimal. And I would encourage you to kind of try this out a little bit, but do these, if you're going to work with the students, do these visuals for them, and do quite a few so that they can see. If you just keep showing them this visual I'm doing for you now, exactly the way I'm doing it, and just change the numbers, they will come to the realization, oh, you multiplied by 10, the digits moved over. So then you talk about the fact that 1 times 10 is 10, 10 tens make 100, 10 times 10 is 100, 100 times 10 is 1,000, and so on. And so when we look at division, we go the opposite way. So here's our number, 253 and 8/10. What I did was I did put the decimal here in its own column, just so that you can see. I'm going to divide that number by 10. Shows that I'm going to go this way, and this great for anchor charts, great for the math wall. So then I move my digits to the right, and now 253 and 8/10 divided by 10 is 25 and 30 and 38/100ths. They need to know that it's part of the new curriculum, but it's that visual, it's that relationship, it's that pattern. And then I just said, for an example, 200ths divided by 10 is now 2 tens. 200 divided by 10 is 20. Okay. And not trying to get them to figure out these rules, take off the zeros, just to have that understanding. Now, this is just another example, but now I put the decimal in with the ones. So it works the same way. Okay. And if I'm going to do any division of whole numbers by decimals divided by 10, sorry, I put this in brackets, but I would have the students write it as, if I know that they're going to, if I'm going to give them practice questions, I would put and 0/10, just so that they see and they don't get mixed up with it. And not even notice the decimal point in that case. But these are the kinds of things that you need to look at, and then you need to practice with your students. Okay. So, and then we're going to go to the rest of them. Determine a decimal number between any two decimal numbers. These are the skills and procedures. Compare, express, and round. Now, there again, you see, they've come with some prior learning, and this is for grade sixes as well in this case, because your students, I don't know if they've come with the greater than, less than, or equal sign, and they'd have to know this now in grade 4. I don't know if all teachers would have taught them that symbol. That's why I left it in black. I think most would have done the symbols for that, and therefore your students won't have any trouble. The only one is the rounding, and that's going to come in very, it's going to be important for grade 6s, especially with the large numbers when you do estimation and to see if your answer is reasonable. So there hasn't been any real work in the previous program of studies with rounding, and so grade 5 teachers and grade 6 teachers, your students may not come with that. Again, I'm going to say probably they did learn how to round. It wasn't in the grade 4 program of studies, but most teachers for estimation would have taught the rounding rule. Might have been in grade 5, but certainly not in grade 4. And then the decimal notation expressed in English and French. So again, with the place value, I know this was mainly grade 5 in this case, but I think the grade 6s, you need to know that you're going to have to do some backtracking, and you may want to consider even reminding these students reviewing place value, because when they work with those larger numbers, it's going to be tricky for them. Okay, and I'm not going to show you this one, but these are just some examples, some further visual examples, and a word problem there for estimation. So I'll put the notes on it. I want to go into addition, subtraction. It's not that it's going to be difficult, it's just the discussion. So here we've got 4, 5, and 6, and look at how similar they are. And I put for grade 6s, the red part is students add and subtract within 1 million, including decimal numbers to thousands using standard algorithm. In grade 5s, it's students up to 10,000 in the new curriculum, grade 4. Now, the reason I put it in red for the grade 6s, because I would venture to guess that most students, now, I'm not saying that they'll have full understanding, but students have probably been exposed to the standard algorithm. We're going to talk about what a standard algorithm is. So we're only doing addition and subtraction. The other session is going to deal with multiplication and division, because it's a little more tricky. But know that all of you, grade 5 and 6 teachers, that your students have probably been exposed to it, maybe tried it. Some may have other algorithms or other procedures under their belt as well, and may want to use that. But the new curriculum is saying that they want them to use the standard algorithm, and we'll talk about what a standard algorithm is. So here it is for we need to focus on the 5 and 6, but I put the grade 4, so the grade 5, you grade 5 teachers can see that a lot of work from the previous program of studies, much of it has been done, and so you won't have so much to do. And the same with the grade 6s. So it says in the knowledge for all 3 grades, in the new grade 4, and they didn't say this in the old grade 4, they talked about they may have worked with standard algorithms, but in grade 4, it's what is a standard algorithm, and they are conventional procedures based on place value. Based on place value is critical. So both of you in 5 and 6, I would go back to the grade 4 new curriculum, and I would talk to them about conventional procedures. What does that mean based on place value? And then grade 5, they're efficient procedures. Grade 6 teachers, they've not heard that. You need to have a discussion on what an standard algorithm is and why you are going to teach it, or why it's not necessarily not why you're going to teach it, why it's a good idea for students to learn a standard algorithm. And then grade 6s, that algorithms, your students are going to learn that they're reliable procedures for addition and subtraction. Now, reliable only if they understand them and can follow the procedures, not reliable if they struggle with them. But you want to say to them, this is what I'm going to show you, and we're going to talk about it, you're going to understand it, because in grade 4, they have to explain. And that's not grade 5 teachers, your grade 4 students will not have that exposure. So grade 5 and 6 teachers, that's one of the things you need to do. Look at that grade 4 program of studies. They need to explain, and you want your students to explain the standard algorithm. And then they do estimation, and you did that before. For grade 5 and 6, your students have worked with estimation, and the reason that they do estimation is they need to check the reasonableness of a sum or difference, especially when it comes to decimals. Okay, we're going to mainly deal with decimals, but whole numbers follow through on that. Lots of money. Grade 6 you have a knowledge statement that they're going to add and subtract the contextual problems involving addition, subtraction, including money and metric measure. Now, money, for all of you, there will be sessions on financial literacy, and that's where you need to look at that financial literacy piece. I've got a few boxes, and I'll make some suggestions for you in my notes. You need to look at that because that's your whole context, really, for decimals, because it's all about money and working with them. Not to the thousandths, unfortunately, but lots to deal with money and the addition, subtraction of them. So now the understanding, again, grade 5, addition and subtraction of numbers with many digits is facilitated by standard algorithms. And grade 6, problem solving context is facilitated by standard algorithms. And I find this unusual because grade 5s, it looks like you don't have to do any kind of contextual problem solving, because it says problem solving context for grade 6 for both, but you do. They have to have real life experiences, and that's where the money and the financial literacy piece come in, or maybe it's baseball stats or any kind of sports stats in general, if you're into that. And kids are, no matter whether they play them or not. But you do have to do contextual problems, but it just doesn't say that in the grade 5 understanding. So again, we're talking about standard algorithms. The word is understanding, so they have to understand what that is. And then the skills and procedures. Again, grade 6s solve problems in various contexts using standard algorithms for addition and subtraction. And there's where I've got the money and the financial literacy piece. And grade 5s, you can see, grade 6s, that the grade 5s will have knowledge of addition and subtraction, some knowledge with standard algorithms or an algorithm. They will have understanding of estimation. Oh, and there it says solve problems. I should have remembered that, including problem solving money. So I'm saying to you, grade 6 teachers, that your grade 5s from the previous program of studies, the old one, let's say, do have some understanding. And grade 5s, the same thing with from grade 4, the previous program of studies. So this is not so, it's not going to be so difficult. You're probably going to do it very similar to what you did before, but you're just going to have that discussion, an in-depth discussion about standard algorithms. And you may have to work on understanding of and procedural fluency in standard algorithms. That's why I'm saying that understanding of those steps or procedures. I don't think I have my little here. Now the next slides, they speak to the standard algorithm. In my research, I found that some math experts believe that the standard algorithm is not the only method of adding and subtracting with regrouping, nor for some students is it the most efficient, because you're going to see, you saw the word efficient, and some math researchers are saying for some students it isn't the most efficient. And that I said, see the knowledge statement for grade 5. And some math experts, now remember, math educators are saying, researchers are saying that there are different definitions for standard algorithm. What is a standard algorithm? Is it what we know with the regrouping or carrying the one? Is it, or could it be something different? And I've got some slides on that. So the new curriculum indicates personal strategies in early grades. So that's not forgotten. The Alberta Learning is not saying you teach standard algorithm and only that. The personal strategies helps the student to understand and come to an understanding of what that addition really means, and then moves on to, as I said, because it is the most efficient in some case. So, and this is while algorithms are valid and widely used, they represent the end of a learning progression. That means I need to understand what's behind it, and then I can follow through and not just do it because I know to put the one there and it works. On the other hand, strategies and algorithms based on flexible thinking, place value, which is critical, and properties of operations prepare students for higher levels of math down the road. So this a math educator is saying it is beneficial for them to know a standard algorithm for preparing them for further math. Conceptual understanding leads to procedural fluency. And I put that there because that's what we want. We want them to understand. I know that sometimes I repeat. Vocabulary, what's an algorithm? So I took this from the website. You've got the site. It's the American one. Make sure you're careful with that. But this is what they say the algorithm is. So it's you've got the word, this great little anchor chart if you want to do that. And it's a step-by-step method for computing. That's what an algorithm is. A standard algorithm is the way most people do things. That's where the word standard comes in. So it's an algorithm that most people use. And so conceivably, it probably is the one where you regroup and carry the one. That because we are assuming that that's the way most students do it. And so in the curriculum, it says standard algorithm, but it's most people. I would venture to say, I'm going to go on a little limb here. If you've got some students who have an algorithm that maybe you've exposed them to it and they can come up with something that's just as efficient, I think they need to be aware of the algorithm you're teaching them. But when it comes to maybe solving a problem, some students may have a different algorithm, a different standard algorithm, especially those that come from another country. Because if you have students from other countries and you ask them to multiply, especially in the multiplication and division, you're going to see a very different standard algorithm. And I've got the definition here that an algorithm is a procedure, a set of steps that can be used to solve a mathematical computation. I put these three words here because I don't know. I hear the word standard, I hear the word traditional, and I hear the word conventional. We use standard. I think it means all the same. Traditional sounds like it's the old way. So my preference is to say a standard or a conventional way. The reason I have that little running shoe there at the bottom right, because if a standard algorithm is an algorithm or a procedure that the way most people do that procedure. Think about tying your shoes. Like I remember I tie mine, I wind it around and pull the knot through. But I remember that some friends of mine, and I don't know if they still do it as adults, but they would make the bunny because there was that little story about making the bunny ears and then wrapping them around. Well, some students, some of my friends, that's the only way they tied their shoelaces. That was their standard algorithm or standard procedures, where mine was a different way. And that's just an example to show you that sometimes I won't say we, but sometimes I'm not sure which is the standard algorithm. And we're going to look at that very quickly. I've given you this site. This is right from Alberta Learning. And I know all I've said. And then here, Alberta Learning says, what are algorithms? They've defined what an algorithm is. It's right on their website. This is not new. This came out in July of 2015. So it was written before the new program of the new curriculum. But at that time, and it's still on the site, so I'm showing it to you, where they define what an algorithm is, and then they give examples. And you can see that the examples they give are the regrouping, the way we used to say borrow and carry, but it's the regrouping. You can see the four operations. Under what are algorithms, it makes me very happy for this statement. The emphasis is in learning must be on understanding. And that's where they bring up again the place value, the base 10 concepts, that relationship between the different places in the place value chart, or between the digits. So this is what they define as the algorithm. Again, you have at some point, I'm going to say to you that there will be a decision that you'll have to make when you've got students who might be able to be more efficient at other algorithms, and you will have to decide, is it important? You're only going to get it right if you do it this way, or you'll get it, it doesn't matter as long as you get the right answer and it's efficient. Efficient is really important. Okay, so that's why it says these are the different algorithms that I saw in when I volunteered or when I taught or when I worked with schools, the different ones. But again, we have to make that decision. Where are we going to get these students at the end? This is this little one here should be up here. I moved the chart. So we have the basic regrouping that we know. We have the decomposing, because for some, this is a personal strategy, and this is one that many teachers will use. Would I call it? That's why I have a question mark beside algorithms. Would I call this a standard algorithm? I don't think it's standard, because I don't think most people or most students, maybe most students in my grade, in my class, would use it, but it is a good way for understanding, and lots of teachers in the earlier grades will work this way. This is using place value, but it's using place value in a different way. Now, I'm going to say to you, there's a lot more writing here, but there's no regrouping. So does this mean it's not efficient because there's more writing for the students to do? And the reason I say this, I bring this one up because this one borders on and relates to mental math. So we've got here, and some countries actually do it where they do left to right, or this one starts, sorry, on the right to left. So 6 plus 6 is 12, 30 plus 10, and the students do not say 3 plus 1. They say 30 plus 10, or 3 tens plus 1 10 is 40, and that's 52. Or this way, 30 plus 10 is 40, or 3 tens plus 1 10, and 6 and 6 is 12, and then they add it. And I've seen that students, and in these two particular ways, it's very efficient for mental math. But again, these could be, you may have students that come with this, but what you want to do is make that connection to this. You need to show them this regrouping, so that they hopefully will see it as the best way and the most efficient way, but they have to come to that understanding. Okay, and that's I said this before, some students have already learned a particular algorithm, so you may have to take time to understand the procedure they're using so that you can make that connection with them. Okay, and this is just another way to show you using a standard algorithm for addition and subtraction, and using that decimal and lining them up. I just wanted you to see that because it's important, but I'll make a note on that. Now, here's where I want to just show you these, because these all come from Khan Academy. And this is where I'm saying, before I would say, oh, I would never watch Khan Academy because it's so procedural, there's no understanding. And then I began to watch his videos, and I'm showing you some snapshots, and I've given you the in each of the slides, I've given you the particular video, and he actually does a very good job. His videos are only about 5 minutes. You may want to use them with your students as a review, but they do a good job of showing an algorithm, but in different ways. So always, I believe that, and Saul Khan confirmed it for me in such a great way that if you're going to do the algorithm, you have to have this is a visual. This is one way to show the visual and make the connections. So what he does is he has these side by side, and he will draw these, or the students can draw them, or they can have the concrete materials, but then he always brings in the algorithm. And the one other thing that he does that's great is notice the color changes and how they match to the place value. So we'll always use a different color for a different place value. So in the video, he will take these, add these blue ones, and he will take them and change the color, group them together so you have the 110, and then go to the symbolic. So you can see this is the 10, this is the 10. Initially it was 12, this is the 12, and he does he only has a few examples, but it makes a really nice develops a really nice relationship. And then he shows you this way. There's all his colors. So again, just a standard algorithm, but he breaks it apart for you. So, and I couldn't have done it any better. So, or at all. So he's showing you that I'm adding 6 plus 8, and he puts that 14 up there, but then changes the color because that's a 10, changes the color because that's a 10. So he's decomposing, taking each of these pieces, and he's showing you what it looks like there. So then he has the regrouping, and then he shows it another way because he's got all of he's got it all up here where he's got the 10 and the 30 and the 90. So he might as well, and so what he doesn't say might as well. So what he does is he shows it this way, which is one of the ones I showed you in that previous chart where we broke it apart into expanded notation and we added them. So these are all algorithms. This is probably the most efficient. You're going to get the answer right no matter which one you do. So when you ask your students, if you're looking for the answer initially, they may do it this way, which is a very easy way to do it. You make that decision. What am I looking for? So, but he explains it all at the same time. So I would do it on a whiteboard with different colors. It may take a little bit of time, but I like that showing the relationship. Then we have larger numbers. Now, he's American, so we have the comma here. I did put a little box so to erase it for you there, but this is just for you to see. This is representational now. Past the concrete or the base 10 by just representing it by a line or a tick or a circle or whatever you want. So same thing, larger numbers, it's showing you, then he just moves it and he changes the color. So he's showing that progression when we add the numbers and then showing it to you in an efficient way with the colors matching. So these are obviously the 10,000s because that's what red is there. I quite like that. And I think for some students, that it would really help. I wouldn't do a lot of work like, you can use his videos to show that. And just like I did, just take a static picture of it because you do have the ability to do that for class if you're using it for class, and then show it to the students that way. And then a subtraction. Again, side by side, he's showing you this is what regrouping is, and this is in this case again there's no visual here, but he's showing you how that works because I can't take one away. So I'm going to borrow 10. If I have 70, I'm going to give 10. And when you hear him, he'll say, so I've got 60 here and I gave 10, so I have 11. He'll use the actual language of the numbers. Again, notice the color changes and how they all match. So for me, for showing you the algorithm, it's to get you to look at this and to say, you may say, well, I understand it, I get it, I'm just going to show them regrouping. I'm going to share a story about something that I did when I taught grade 6. It didn't have to do with addition and subtraction. It did have to do with multiplication. And if you don't come to the multiplication when you'll see why I'm saying this story. I love math. I thought I was doing the right thing. I had a little girl in my class and she really struggled with regrouping in multiplication, really struggled with regrouping. And we worked at it. And I remember the day that we worked I hate to say this, but it was a board, not a whiteboard, and a blackboard. And I did some examples for her, and we walked through them, and it was regrouping. And I started with no regrouping, and then we went into regrouping. But because she's also struggled with her basic facts and multiplication, I didn't want to do too high of the numbers. So I would do like 4 times 3, 5 times 2, 6 times 2, those numbers that were easy to multiply so she didn't struggle with the basic fact. So then I gave her some questions to do, and she didn't get them. She didn't give them, didn't get them all correct. And I was just so upset and I couldn't figure out. And I asked her, I said, can you explain to me why you did this? So the bottom line was when I did those examples for her, as I said, I did all easy questions. So everything I regrouped, when I regrouped to the tens place, it was always a 1 because it was 12 or 15 or 16 or 18. It was not anything like 4 times 6, which is 24, which means then you regroup and you put 2 above the tens. Every example I gave her because of the easy basic facts, was a 1. And when I gave her questions to practice, it was beyond that. And she only put a 1 above every 10. And when I asked her why, I said, can you explain why you did that? And she said to me, well, you only ever put a 1. So I thought that's what I was supposed to do. So, yeah, I mean, I'm telling you this because you have to be so careful when you do this. Any little thing, these students struggle with this, and when we get into multiplication division, it's going to be even more so. But for all of the operations, that regrouping, don't make the mistake I did. I mean, I went home and I cried. I was devastated. I just thought, oh my God, that poor girl, she was trying so hard and it was all my fault. So just be careful. You mean well, and especially with this algorithm. So, and there's, okay, so this one here, I'm just showing you, this is just some of my added slides, because it just shows you the concrete. This is the decimals. Now we're adding decimals. Sorry, I should have put the title page. But when we look at decimals, we go from the concrete to the representational, which is where we're looking at the little dots. And again, it's no different than whole numbers. We add, when we add, we regroup and we go to the left. And then the same thing when we add it together in the symbolic form. When we write it like this, notice that if you've got, I tend to I will suggest to the students, if it said 3 4/10 plus, I'll say 3.4 plus 4.87. If it's written where the 3.4 is written first in a horizontal format, I'll talk about how it might be easier if you've got more digits after. You might want to start with that one first, but that's only for addition. Or you want to do that 0. And I would, that where the values are the same, that 4/10 is the same as 40/100. So get them to put that 0. Make sure that they're practicing that so that they know how to add the numbers, because sometimes when that space is there, they don't have a clue what they're supposed to do. Okay, and this is the different strategies. There's the horizontal format, and then there's the vertical. Always get them to transpose. Now, the reason I'm showing you this is because of the decimal point. So I think one of the best things you can do is to have grid papers. My son had to use grid paper when he did addition and subtraction of whole numbers when he was in grade 2, because my son wrote all over the page. He felt he needed to fill every space. And so I bought a scribbler. I went to the university because I wanted the 1 centimeter, but you can buy centimeter grid paper, make them into scribblers if you want. You might even be able to buy scribblers now like this, because of this. Now, this is all the different forms. I've got subtraction, all 4 operations, but you want that because of the place value, you want those numbers to line up. And for some students, they won't line up when they just have to write them in their own, whether it's on a whiteboard or whether it's in a scribbler. So I think grid paper is one of the best things that you can have. It's just a little tip. And then be careful on your wording. So when you're explaining, and for yourself, what do you say? And these are just a couple of things. So when you're looking at the number that I've got here, the 45.86 plus 23.13, if you say, add the numbers to the right of the decimal point first, and then the numbers to the left of the decimal point, students may end up doing this. And I saw this quite a bit in the grade 6 PAT when I had to analyze their responses. So they would add this number and put everything to the right, and they wouldn't do any regrouping. So this is just a reminder. If you say this, add, because you want them to add, you want them to start from the right, but to say to the right of the decimal point first, you may end up getting something like this. Or again, I've just mentioned this, with questions that are presented in horizontal format, they may remember to say that this is the same value as 3 and 50/100, so that they can write them underneath each other. And that's where the grid paper comes in. And that's the knowledge statement from grade 4, but it's also in grade 5 as well. So just things to be careful with. And now I'm just going to end with a few activities. We've only got 2 minutes left. These ones they're just little games. So this I'm just going to end with little things that you can do along the way. And one of the things, it doesn't matter, this is your grade 5 and 6 teachers, your grade 5 and 6 students, but they still need to know. And we're only doing addition and subtraction with basic facts. So what I have here, this is a product game, and it's actually interactive, but this is for multiplication, but what I did, and when you show this to your students, you can move these. The idea is that what will happen is that one student will start and they'll take these two circles and they'll put them on any two numbers. They'll multiply those two numbers, 3 times 6, let's say. I'm not going to, I have to go out of this format if I want to show you how it works. Let's say they do 3 times 6, and the player 1 will take their orange and they'll put it on 18. Then it's player 2's turn. They'll always play with the same 2 green ones, and they will take one of those green ones and move it to another number, let's say 8, and they'll go 3 times 8 is 24. Take their purple one and put it on the 24. The idea is to see who can get 3 or 4 in a row. What I did is I took that and I just changed it to addition, because you need to do addition. So this is the same game. You can do it you can show it to them on the slides, but all I did was I changed the board. I went 1 to 18 and 1 to 18, but I changed it from 0 to 9 because that 0 was so important. So I just made the game the same way if you're going to do it with the students in this format, but this one is much easier. Okay, using 10-sided dice, much easier. So roll the 10-sided dice, whatever you get, whatever the person gets, they add if they want. You don't need this. Then the other person will only roll one of the dice. So the first person rolls 2 10-sided dice, and from then on after that, you only roll 1 dice. And then if you can fit that number in, makes it a little bit more challenging because you don't determine both dice. You only can roll 1 dice and 1 stays the same. So it's a little bit of a different game, but same thing if you want. Or you can do this. Put your 2 counters, 0 to 9, your 2 bingo counters, or colored counters, and then you can put your own colored counter, the same as the previous game, on the board. So there's 2 ways of doing it: to roll the dice or to use the counters here at the bottom, but the kids need that. And you can say, okay, you can choose subtraction. Only do a multiplication, addition and subtraction just for this particular these particular outcomes. You could add multiplication if you wanted, but I would stick to addition and subtraction. Start with addition and then say, okay, if you want to do subtraction as well, you can choose. So you get the 4 in the row. And there's how to play the game with the product game, and then you just change the rules. And then these are other games that you can play. Very simple, very easy to do. Piece of paper, mini whiteboard, whatever you want, but it's just, and this one is playing with dice again, it's just getting them to do their basic facts. This is an activity for adding and subtracting decimals. I'll explain how to do that, and another one it's a different one to get 4 in a row, and because it's got thousands, which is really important for grade 5s and 6s. So these are just the different activities that you can do. I'm going to, before I say thank you, I am going to give you the explanation for password. I'll go back to this one. And I'll show you how to play that game. Password is great for vocabulary, and it's similar to concept attainment, where you will say a word that's a vocabulary word if you want them to say algorithm and you've taught it. So you'll say procedure, just like password on television. So it's using those vocabulary words, but in a way where you can only give 1 word clues at a time, and the idea is for them to try and get it. So, okay, 2 minutes over. I'm finished. Oops, I've got 2 questions in the chat. Thank you very much. Okay. Yeah, I think there's a question about sending the links. Yes. Philomena, you'll get the links. If you were in another session and you should have make sure you let me know that you got those slides, because I know that you were at a session, but yes, you'll get everything. Now, I can't get them to you tomorrow. I know that because I'm going away, but as soon as possible, I will. I'll have those for you. So, okay, I'll just stop sharing here. I'll stay behind for if anybody has a few questions. Other than that, have a great day. It's really nice out here in Edmonton if you're here, and relax and go home if you're at school, and take a rest. Okay. Thank you. Thanks very much. Thanks for coming. And remember, those Oh, we're good here. I don't know who's still here. So Carrie, if you haven't been here before, if you've not come to a session, know that if there's a session that you see that you may think the slides will benefit you, you're going to get the slides if you register, even if you are unable to come. So if you see a session that you think you might like to go to, but you might like to have the slides for, but you can't go to the session, register anyway, because I'll send you the slides. And if you don't get a chance to register and you see it too late, like you're looking, you thought, oh, I didn't see that session, email me, because you'll get, my email will be on the slides and I'll send you the slides.
Can you hear me?
I can hear you, Carrie.
Okay. I couldn't get my mic working. I was just wondering if you could explain that password game one more time quickly.
Oh, okay. That was so fast. Let me go to it, okay, and then you can see. And
Thank you.
I'll make sure that you get the directions for it.
Oh,
I'll,
okay.
I'll
Okay.
put them in the notes. So
Okay.
that was the wrong one. No, here it is. So the idea is that you give the clues. I did this with teachers in another district, and the kids play back and forth. So I give you a clue and I say apart, and you have to think of what math word means apart, and then you do it with the kids. But it's after you've taught it,
Yeah.
taught it with the students, and then I give you another clue, number, and then another clue is partition, which is a better clue,
Yeah.
and break, and then the word is decompose. But that's only if you worked with that, yeah. So
Yes,
and
I
then
did. Okay.
yeah, measure, unit, short, imperial, and it's
Mhm.
inch. So
Nice. Okay. Yeah,
yeah,
that's awesome. That's really good. That's fun.
that works. Yeah.
Okay, thank you so much. I
Thank
really
you,
appreciate it.
Karen.
That is
Yeah, have a good
so
evening.
much great information.
Thank you.
Have a good
Okay,
night.
you too.
Thanks.